Welcome to Statistical Study Program of Universitas Islam Indonesia. We are the first study program established at Faculty of Mathematics and Natural Science in 1996. Now, it's also the first and the only private statistics study program with accreditation status A. We implement enthusiastic curriculum in our study program, comprising 5 scientific interests: LIA, data science, actuarial science, statistical research and management, statistics of social and business, and statistics of industry. With statistical study program of Universitas Islam Indonesia, genggam data, kuasai dunia.
Statistics study program has 3 laboratories. They are a disaster management statistic laboratory, a business industry social laboratory, and a data mining laboratory. The facilities provided from the laboratory are a high specification of computer and laptop in various brands, software, and university provide us with high-speed internet connection. Laboratory service focus on supporting Chatudharma activities including teaching, conducting research, performing community service, and doing dakwah Islamiyah. With Statistics Study Program Universitas Islam Indonesia, genggam data, kuasai dunia.
Genggam data, kuasai dunia.
Dawn again greets us beautifully. A bright and glorious future gives us happiness and perfection. We, the Master Program in Statistics UII, are founded to produce globally competitive graduates in analyzing data and statistical science advancement. The Master Program in Statistical UII is one of the master programs at UII, which focuses on business, industry, social, and actuarial, data science, spatial, and bioinformatics. We first established on September 21st, 2022. We provide education according to national standards that are globally oriented such that graduates can play a role at the national and global levels. The Master Program in Statistics UII is a pioneer educational institution that prepares its graduates to become experts in data analysis and integrating the MBKM program. We are located in Professor Dr. Haji Zanzawi Suyuti Building, Yogyakarta Spatial Region. The Master Program in Statistics UII works confidently, has a strong commitment, and is supported by competent human resources, up-to-date facilities and technology, extensive network partners, experienced and accredited by BAN PT Higher Education. The Master Program in Statistics UII aspires to become excellent in data analytics and the development of statistical knowledge to advance science and technology through teaching, multidisciplinary research, graduates who are competent, flexible, innovative, and have excellence in Islamic principles. The learning outcomes of the Master's Program in Statistics are summarized into creative minds, namely excellence in communication, producing outstanding research, professional entrepreneurs, strong analysis skills, up to date with technology, having Islamic ethics, understanding of differences, responsible elaboration, managerial data skills, creative in innovation, proud to be Indonesian, having diagnostic abilities, and leading in science. To provide the best service for students, the Master's Program in Statistics UII provides international standard laboratories to support the learning process and research activities. They are Risk and Disaster Management Statistics Laboratory, Business, Industrial and Social Statistics Laboratory, Data Science Statistics Laboratory. Various campus facilities at the Master's Program in Statistics UII are provided for students to get the best experience in studying and doing activities during their studies in UII. We are committed sustainably to developing and improving the service to provide the best educational services. We strive to create a new future through innovation, research, and passion that benefits all humankind. Wherever you are, come and join us and be the best partner of life.
Welcome, Professor Hassani, to this event. Thank you for your time with us today.
Good morning. I hope that you can hear me very well.
Yes, we can hear you. And I think we will start first, Professor.
Sorry,
Pardon, Professor?
I couldn't hear you very well.
Oh, is the other hear my voice?
Yes,
Okay, thank you. I will start the event first, Professor, and thank you for your time.
please.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi wabarakatuh.
Well, ladies and gentlemen, before we commence with today's event, let us take a moment to express our gratitude and praise to the Almighty. With hearts filled with gratitude, we offer our thanks to Allah Subhanahu wa Ta'ala for granting us this virtual gathering today. In the spirit of joy and reverence, let us also send blessings upon the Prophet Muhammad Sallallahu Alaihi Wasallam. Peace and blessings be upon him. May our time together in here today will be blessed, and may the knowledge that will be shared bring benefit to us all. Now let us extend our warmest greetings to the Honorable Dr. Hossein Hassani from Webster University, Vienna, Austria, Dr. Georg Heiler from Vienna University of Technology, Austria, Mrs. Dina Tri Utari, MSc from International Program of Statistics Department, Universitas Islam Indonesia, Dr. Rahmatul Fajriah, MSc from Statistics Department, Universitas Islam Indonesia, staff and lecturers of the Statistics Department and the SBRC team, and of course, all of the Excellencies participants. Good morning and welcome to our event, Statistics and Bioinformatics Research Center Webinar 2023, with the title, Mapping the Future, Bridging Data Science and Spatial Statistics with Visionary Insights. This is a collaborative event between SBRC and International Program of Statistics Department. With me today, Zahra Maharani as the master of ceremony of this event today, and please allow me to introduce you to our agenda today. The first one is opening, welcoming speech, recitation of Quranic verse, the first webinar on the topic Decoding the Data Universe, Unveiling the Power of AI and Machine Learning in Transformative Decision Making by Dr. Hossein Hassani, question and answer, break, the second webinar on the topic A Spatial Statistics Perspective on Futures Landscape by Dr. Georg Heiler, question and answer, and the last one is closing. Well, ladies and gentlemen, without any further ado, let us open this event by saying Basmalah together. Bismillahirrahmanirrahim. May Allah grant smoothness to this event today. And stepping to the next agenda, which is the welcoming speech, that will be delivered by Mrs. Dina Tri Utari, MSc, from International Program of Statistics Department, Universitas Islam Indonesia. To the Honorable Mrs. Dina, the screen is yours.
Thank you, Zahra. You hear me well?
Yes, Mrs. We can hear you well.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh. Good morning, everyone. And here I'm delighted to be here as the representative of the Department of Statistics to welcome you all to this webinar. And today we have fantastic speakers, Professor Hassani from Webster University and Professor Heiler from Wien University, Austria. And in this webinar, we will dive into the data science and spatial statistics, and then exploring this field exciting possibilities. Whether you are from the professional or the starting, this is a great place to learn, connect, and share ideas, I think. And then our speakers are expert in the data science, Professor Hassani and Professor Heiler for the spatial statistics, ready to share insight and real-world application today in this webinar. And then this agenda is with the diverse topic, catering to everyone from professional to those who new to this field. And then from the department, maybe we want to, all of you, let's build connection, expand our knowledge, and contribute to the vibrant community shaping the future of the statistics. And then once again, thank you, Professor Hassani, to joining with us in this event. Thank you. And then thank you for the participant. And then I think here's to an inspiring and collaborative webinar. And then, yeah, we hope you all enjoy this experience. We can learn specific in the field of data science and also spatial statistics. Thank you once again, and maybe I think it's all from me. Thank you, Mbak Zahra. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to Mrs. Dina for delivering the warm welcoming speech. And now we'll step on the next agenda, which is the recitation of Quranic verse from Surah Al-Mujadilah, verse 11 to 13, by Ahmad Saiful Jamil. So to Mr. Saiful, the screen is yours.
Okay, thanks to Ms. Zahra for the time given to me. Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. يا أيها الذين آمنوا إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم وإذا قيل انشزوا فانشزوا يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات والله بما تعملون خبير. يا أيها الذين آمنوا إذا ناجيتم الرسول فقدموا بين يدي نجواكم صدقة ذلك خير لكم وأطهر فإن لم تجدوا فإن الله غفور رحيم. فإذ لم تفعلوا وتاب الله عليكم فأقيموا الصلاة وآتوا الزكاة وأطيعوا الله ورسوله والله خبير بما تعملون. صدق الله العظيم. Assalamualaikum warahmatullahi wabarakatuh. For the next, I hand it back to Ms. Zahra.
Thank you, Mr. Saiful. May the recitation of these holy verses bring blessings to both the reader and us as the listeners. Amin ya Allah ya Rabbal Alamin. Well, ladies and gentlemen, before we continue to our main event, we will have first the photo session with Professor Hassani. So, to all participants, please turn the camera on and use the background image that has been given by the committee in the chat column. Once again, before we start the webinar, we will have first the photo session with Professor Hassani, our speaker. So for all participants, please turn the camera on and use the background image that has been given by the committee in the chat column. We will wait. Okay, I think we can start the documentation. Count me, 1, 2, 3. Okay, once again. 1, 2, 3. Okay, thank you. Okay, ladies and gentlemen, all of the participants, now finally we come to our main event, which is the webinar topic Decoding the Data Universe, Unveiling the Power of AI and Machine Learning in Transformative Decision Making, and it will be delivered by Professor Hassani. And this session will be moderated by Dr. Rahmatul Fajriyah, MSE. So without any further ado, to the Honorable Ms. Emma, the screen is yours.
Oke, thank you Mbak Zahra. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, and also welcome to Professor Hassani. So today I'm becoming your moderator from this webinar. And before it starts, I would like to read about your curriculum vitae about Professor Hassani. So Professor Hassani is a highly accomplished and skilled data scientist, academic and researcher with over 15 years of extensive experience working with national, international, and multicultural organizations, research institutes, and academia. He has held a variety of leadership positions, including statistical system coordinator position at the Organization of the Petroleum Exporting Countries, which is OPEC. And he has also worked with renowned organizations such as the United Nations. His education is from for a bachelor degree, which is in statistics from Razi University. And then for Master of Science as well in Statistics, which is from Shahid Beheshti University. And then for Doctor of Philosophy, which is in Statistics as well, from Cardiff University. His current position is now he is becoming the Director of Data Science and Technology Innovation, which is in Austria from April 2023 until now. And as a senior research scholar, which is in International Institute for Applied System Analysis from last year until now. And then at Webster Vienna Private University since 2018 until now. And then I already mentioned about he has been a United Nations consultant, and also he is in the international health statistics expert. You can also find about the information about him, which is in LinkedIn. You can try to find out which is the account is Hossein Hassani. Maybe that's for the curriculum vitae of Professor Hassani. And now I would like to give the time to Professor Hassani to start about the presentation. Professor Hassani, the time is yours.
Thank you very much indeed. Assalamu alaikum and good morning to you all. I hope that you can hear me very well. Do you hear me very well?
Yes, I can hear you very well, sir.
Yes, Prof.
Okay. And thank you for having me here today. It's a great honor and pleasure to be here. And Alhamdulillah, I can see you very sound and good, which is the best thing in life. And I like the opening remark by my sister that said that we should thank God and Prophet and everyone in the earth that we are quite good and healthy, and we have this moment that we can share with each other, at least for something better. And thank you for kind invitation and also kind words about me. I do apologize for a few minutes late. I got the time wrong, but if I may, I had a chat with you, and we have a diverse audience here, and because the topic is about data science, how and machine learning and AI can change this. If I add a little bit more word about myself, I'm heavily involved now in AI, data science, and machine learning, and digital twins, working on this area. And in terms of few other jobs that I'm currently doing, I'm doing a project now with the UNIDO, United Nations, which is about nowcasting forecasting for SDG. I'm working with WHO Philippines now. WHO, we are doing a project for children and the quality of baby in the Philippines. And we started now, we're implementing this. And next week, I'm participating and presenting, invited for the high-level meeting, and how we can use the digital twin for official statistics for high-level official statistician in Geneva. Why I'm telling you this? Because the core of statistics and data, and also at the same time bringing the new method, it's quite vital and important. I'm glad that you are tackling this issue. Through the discussion that we had together, we have diverse participants now. Some of them are my great colleagues and friends who we are joined before, and I had a session. And if you permit me, I don't know how, a little bit a word, and I prepared the first part of my presentation. I did it for your colleague before, they like it, and I would like to do the same, because to me, the youth, I'm working with youth and the young generation. To me, these are the future leaders. And therefore, they have a special part in my heart. And a couple of last years, I started investing a lot on youth and young generation, particularly if we look at the university, the bachelor students, which is, to me, the quite important part of the journey to be the next leader. If you kindly shared with me the composition of participate today would be good now. Percentage-wise, what are the percentage? We have a bachelor students, what are the master and the PhD? So I can diverse my time, but at the same time, I would like to be like more Q&A rather than me presenting something, because that's why you learn more, and I can learn more from you. So I can talk a lot. I can share my experience with you. I think more by Q&A. So please, can you share me the percentage-wise the rate for bachelor and master or professional that we have today, so I can divide my time accordingly? roughly? Of course, it's difficult to say.
Wait a minute, let me see. I think for master and PhD in here, maybe about 20%. And then mostly about undergraduate, which is, about 80 or 75%. So more or less 25, 75%.
Okay, so
Yeah.
so if you permit me, I would start with the very basic, and I had a presentation before. I try to bring it up again and share it with them, which is encouraging for them. And then I show you a couple of application maybe, and then I have various application, but it's much better. We talk like a Q&A. So they have a question, then I would be more than happy to answer. Maybe that's more useful for them, because they need to know their way, and therefore they can invest in those areas. So let me share with you a couple of slides that I had it before with the audience. I hope that you can see the...
Yeah, we can.
Okay, perfect. Well, that's a bit information about me. I encourage those people and those are interested to look at my LinkedIn you mentioned kindly. All my publication available on ResearchGate. In addition to what my sister said about myself, I heavily involved in academia, and I still publish a lot. In fact, this morning I was revising another paper, like you, that you are involved in academia, but at the same time, I heavily involved in industry and international organization. I will talk a little bit about that. Please link with me in LinkedIn. I share time to time, every week, a couple of research work, and then we will see how data and playing with data, it gives you lots of information. And this is our job, to look at the data and the data science now, which is the backbone of everything now, to me, because the data is growing and we need to be fit in this area. So that's a little bit information about me, and you can, as I said, link with me the QR for the LinkedIn. So when I'm looking at myself, as I said, with the kind introduction, I'm fusing myself in 3 areas which I benefit a lot. Why I'm mentioning this? Because for young a statistician or scientist, it's quite important that you are not just one direction if you want to be more successful, because what you can see from official statistics, that's fantastic to bring it into science. At the same time, what you see in science is what would be fantastic to bring it in industry. That's fusing something. That was the aim. I published a paper about big data, blockchain, and cryptocurrency back to many years ago. And therefore, this fusion is always with me. And if you look at the research, if you are doing to me, I defined in my book, the research, for me, the definition, it shouldn't be something that you think, wow, I should create something that the world has not created yet. No. To me, the research is rethinking, because I'm sure in your esteemed country, you have lots of good scientists in the past. If you look back to 500 years ago, even 400 years ago. You have lots of great scientists, visionary scientists. But then now, if you think about it, evaluate and republishing perhaps those ideas in a different way, because everything has been changed. To me, that's a research. That's my definition, and I'm always trying to do it. So that's my prime definition for that. So don't think that it's changed. At the same time, to me, now the data is the backbone of everything. So don't look at the machine learning on AI without the data. If there is no data, no machine learning approach work. If there is no data, no data science work. There is no data science, in fact. Data science means data. The name comes with it. Machine learning with data. So this is from my students. Put one of my words in a nice format. She was in my class. I was talking about this, and I had the quotation. I said, and then you start very good motion. So it fits very well after 2 days. When I change it to big data, I said, is the art of the life is adding one more friend into your friend list every day. So instead of adding one more enemy into it, let's turn on life like a big data, adding friends at an exponential rate. So that's my vision. And why I'm telling you this, because we are exploding our life with the data. And therefore, we have to use this data in our daily life. So let us start with a very simple theorem. I don't know how many of us here are statistics. Do we have any those that PhD or master or professor working on time series analysis here?
Yeah, mostly we are working on it, Professor.
Ah, fantastic.
Yeah.
Yeah, that's brilliant. You know, a few years ago, by the way, I have a very good colleague, Vinita, here. I think she might be here today. She's worked on one area that I developed a lot on SSA, which time series analysis. But back into the classical time series, now I'm inviting those master, PhD, and even professor working on time series analysis to have a collaboration work now. A few years ago, I discovered something which is called Hassani's minus half theory. And the fact is telling me that the sum of sample ACF at any length, like greater than 1, is always minus half. Nobody believed that many years ago. But that's a fact. And I have a various publication on that. I invite you to, if you find any application, collaborate with me. And I'm publishing a lot now, and the pipeline is coming now. In fact, I'm revising another one. I published 1 month ago. Now I have a PhD student, so we have many papers coming. It's changed the whole history of time series analysis, by the way. And if you look at my publication, I publish a lot. And in this area, I'm #1 in the world, by the way. On 2 areas, I'm #1. One is singular spectrum analysis, which Vinita from your esteemed country is working on it. If you look at the Web of Science publication, you could see that. On this one as well. So I invite you, those professors working on time series, look at my publication on this and let's collaborate. And why I'm mentioning this, when I was a PhD student, I discovered this by working on data and data science. So I'm playing even with Excel file because I did it with the MATLAB that time. I found it is true. Then I didn't believe it. I started working on the Excel file. I write a program in Excel. I thought it's fine. I write a program in R. I find it's fine. Why this is important? Because it shows that the time series that we are using today is basically misleading. Because if you make an ARIMA model with the P and K, is wrong. Because basically, there is no time series in the world that all ACF is positive. That's the meaning, simple meaning of that. It has lots, but I would be more than happy during Q&A to mention this. So I was talking about myself. I said why it's quite important. I consider myself, I had a very good mentor, professor, colleagues, and peers that helped me, and students and junior. That's fusion of me, and I would appreciate if all your scientists in field of data science consider these three aspects to grow up, to work, and to have an enjoyable time for data science. But let's back to the business. I talk about a little bit big data because, again, the backbone is data science, is a big data. And therefore, you hear lots about 3V, 5V, 10V of big data. We are producing massive amount of data. Now the data is generated on exponential curve. Now I'm talking to you. I think Zara take photo. That's the data. She was talking. That's the data. Then Amital is talking about my CV. That's the information and data. How many we are here? We are producing data. 70 participants we have now. It's data. Therefore, you would see that we have lots of data. Therefore, bringing this data, and it's a various form. We have a picture, we have an audio, we have text. Then, therefore, all of those are the data, and we need to use it. And believe me, international organization, including United Nations, now we are looking at the open source data. And I will share with you today the tools that I myself developed. By the way, I'm creating lots of apps as well as a data scientist. So we generate the tools and software based on R that I'm sure you are using. And using the data from Twitter, from X, I mean, now it's X, News or Google, that you can bring lots of information and generate new view and prepare lots of good amount of information for official statistics. So now my mobile is generating, my computer is generating data, myself, my credit card, and all of them, they are generating information and data. In fact, I called myself that I'm a sensor now. I'm a moving sensor. I'm generating millions of records. And therefore, someone needs to use this data. The title is for decision making, how we can use this data, machine learning. Therefore, you need to bring this out, all this information, either it could be sound, image, text. And I will share with you today one of my recent paper, because at the end, that I use this technique, machine learning and AI, for the real world, that data on the Twitter, or X, it's better I call it X now. Because our friend Elon Musk, he doesn't like it to call it Twitter now. So I call it X. So that's the whole. Do you have any questions so far?
Hello, participant. Do you have any question to Professor Hassani? Maybe particularly who work on time series data analysis? or maybe the new student, the undergraduate one, do you have any question about what Professor Hassani already explained, please? Okay, there is Alicia. She would like to ask you some question. Go ahead,
Please,
Alicia.
go ahead.
Good morning, sir.
Good
I
morning.
hope you have a good day today.
Thank you.
The questions I would like to raise in this occasion is that, as you mentioned before, that big data is a collective data from across the digital platform. Does it usually collects data based on our permission, or do they just collect anything that we have shared in the social media or any digital places?
Well, thank you. That's a very vital question. And to answer, well, I work on, by the way, AI ethic as well. And I'm sure that if you are following me on LinkedIn, I had a post on it about AI ethic as well. And I look at it much bigger than even data. I'm looking at the AI ethic now because now it's not only the data, it's your image, it's your voice. And you know that the AI tools now, if you take a photo of me, you can create whatever you want from myself now. So it's a bigger danger that only the data and sharing with it, but that's a concern. As soon as, but to answer your question, I would like to invite you to look at one of my LinkedIn posts, which I talk about data slavery. To me, we are now a slave in a modern way. We are generating data, and they are using our data. You like it or not, and you hear lots about bringing this big company, a small company, to the court because of the sharing information, because of the misuse of information. But still they are there, still they are growing, still they are producing more app, and you are using it.
Yes.
Because you cannot, when you are using, say, X, you are using a social media platform, and for example, they ask you, we share this information, read this by doing this. You don't read it, or even you read it. If you do not accept, you cannot use it. So you see, the technology is forcing us to agree at some level, but the concern that we have, to me, it came in bigger and bigger, and you will see that with this AI. Therefore, I'm working with my colleagues, various of them, on AI ethic. And unfortunately, the speed that we can see in the AI is much faster than human to have some rules and regulation in place. And that's always we are lagging behind because of the nature of the work, because of the lots of hassle and regulation that we have taken time to implement those. And also country by country, they have a different structure, they have a different culture, and that's make it more difficult. What we have in Europe, we don't have it in Indonesia. What we have it in Indonesia, we don't have it in Japan. Because there are two different culture, two different structure, two different regulation needs to be implemented. And that's make it more even difficult. Therefore, you will see all of this. But that's a very important question. There is no unique answer for it, and there will be no complete answer for it as well. As I show you in my recent post, this ethic, I move it more. It has been with us from cave. The human sharing food, they have ethical. Faith, religion, we have always ethical with it. Therefore, it has been with us. Now we see the different notion of it. I hope that I could answer this question. Any more before I move ahead?
Thank you for your answer, sir.
Professor, there is one question in the chat box, which is from, she is our secretary department of statistics, and she is working on time series as well.
What is the
So
impact of your theorem minus station model? I'm sorry. Okay. Well, basically, thank you for this. The impact is all time series wrong. Basically. Why? Because it's telling me that, in reality, I published a recent paper, look at it, it's about line memory process. Whole definition based on line memory is wrong. So when you detect the memory, your time series is line memory is wrong. When you detect the time series is short memory is wrong. When you detect a model, which you say is ARMA model 2 and 4 means the parameter P is 2, Q is 4, is misleading, is wrong. And if you look at those, if you read my paper, I mentioned a couple of them. Many of the big professors in time series, they come up with the different rules to find P and Q, and they are very famous in time series, and they mentioned that the test is not working, is not proper, but they didn't know why. And they come up with a different solution, but they didn't know the backbone, why is wrong. Till I found this phenomena, and then I published another paper with my PhD students, and we propose alternative solution for it. Still, I'm working on it. Still is quite new, very brand new. And I'm sure it changed the time series, but it takes time. And you know that those that they get Nobel Prize, when they are close to die, they give them the prize. and I'm very optimistic about this. And I hope that I don't want to get the Nobel Prize, but it will be a big recognition for this, because basically it's telling us the time series that we learn over the many years and decades is not correct. And I don't blame them, because 30 years ago, 40 years ago, when we have all this theory, we didn't have computer, honestly, to do. So whatever they did, they say, oh, asymptotically, it's follow normal distribution, or asymptotically, it goes to 0. For example, for line memory. But I proved that asymptotically precisely goes to -12 and not 0. So if I answer you, the basic is there is no time series with positive ACF in practical. But in theory, you have lots of book. Just to make it in bracket, when I found this, I went to a professor back to UK when I was PhD students. When I presented to him, he said, he told me that your observation is wrong, because I have many PhDs and I look at my book. I have 5 books on time series. So you are wrong. He asked me to write it on the board. I said, I did simulation. I said, no, I don't agree with simulation. Write it on the board. So I proved to him, and he said he was shocked. And now we published a paper with him, and we criticize the work. So that's why I invite you to join me and to work on this area, because that's opened up a new field for research. Okay, thank you for the question.
Okay, there is another question which is from Bu Ani Budi Asusi from University of UB Brawijaya. You can read it from in chat box, please.
Okay, one of the challenges of big data is how to guarantee the correctness and suitability of the database on big data. Okay, that's a big challenge, and it's always a challenge. And I want to show you one example of my work on data science and AI. After I finish the first part of the presentation, definitely I will show you two applications. One is about the app that I generate, and the second is about publication out of this app as well, just to encourage you to work. Definitely the big data, one of the V that I was talking here as well, is about the veracity of the data. So when you have a velocity of the data speed, that we generate more data, but at the same time, you have a data from different sources now. If I look at your esteemed country, you have one data. If I look at your official statistic, you have another data. If you look at the other, even for one, say, inflation data, you have different information. Then when it comes to big data, when there is no stamp from official statistics, it would be more and more noisy. Therefore, it's difficult to get a proper data, but at the same time, the statistics give us tools to work on that based on what we would like to do. Today, I will show you with the Twitter data, with the X data, that how I did it to eliminate those not quality data to have a better data for analysis. And we have a saying in a statistic that garbage in, garbage out. So if there is no good data inside, therefore the output would not be good. So I look at if we have any other question in the chat box. No, I can go ahead, seems that, yes?
Yeah.
Okay, thank you for Q&A. And I don't like just to talk, because after 10 minutes you get bored. And then you don't listen to me. I do this in my class as well. And the way that I teach a statistic, I play with the data with my students anyway. And I love doing that. Okay. Yes,
Another
Diana?
question, yeah.
Dina, yeah, go ahead, Dina.
Yeah, thank you, Professor. And you said before that you are also working on the digital twin, right?
Yes.
And then, yeah, like the simple explanation about the digital twin is like the virtual copy of real world system, like in plane.
Yes.
But my question is digital twin possible to be implemented in healthcare, for example, in cancer patients?
In healthcare?
Yeah.
Okay. To me, the future is digital twin. Because we are preparing ourselves many years ago to have a digital version of ourselves, human, to have a digital version of car, to have a digital version of building, to have digital version of city, and therefore to have digital version of world. That's we are working without knowing it. We are preparing. As human, we are preparing lots of data and information that needs to be fit in the digital twin. As those that they work on the tech, they preparing the 5G or communication or connection technology or ITC to be able to transfer this data to the twins. As those that they work on technology, machine learning, AI, and those to be able to model and to make it the twin more similar to human. I'm pleased to inform you that I'm working with the Director of Health and Statistics in WHO, and we are writing a book about digital twin and in healthcare. In healthcare, particularly, I think your question was about healthcare. Particularly in healthcare, we will see more and more in digital twin version. And we, at the same time, when we see lots of concern about it, and I will explain a little bit about it, but we see a huge benefit about it. Simply means you have now, for example, looking at this issue, now you have me, I'm talking from Austria, 5 o'clock in the morning, talking to you in Indonesia, which is 11, 12 o'clock now, I think, in your time. And you see that this is the communication technology help us. So assume that you are in a hospital, your doctor is communicating and he sees it when during the operation, give advice, but at the same time, they can operate. And digital twin and the tools and IT, in many aspects, they are more accurate than human. In many, because it's like ChatGPT. You see, you ask a question, yes, there is some issue with it, but the human has an issue as well. Do you have all the doctors, they are perfect? No. They don't do mistake? No, they do a lot. They do a lot mistake. So we should accept the machine and the algorithm do mistake as well. And as I said, you like it or not, we like it or not, we are going towards that. My idea is to prepare ourselves rather than be against it or to make it criticize. And that's why I'm teaching my children who is 6 years old to prepare him to know his right and to know how he should use better AI and technology to prepare him rather than to be in a situation. So to conclude, the digital twin in healthcare, we will see more and more, and we will see more and more the benefit of it. Of course, there is always concern as well. That's with the human too. Thank you.
Thank you, Professor.
Thank you. I think no more question. Can I go ahead?
Yes, please, Professor.
Thank you. Thank you for all questions. I love to have a Q&A, you know, because that's why we learn. So anyway, let's move on. And the beauty of the data to me and the fantastic application that we can see now, to me, which by the way, that's a recent area I'm working on, is I'm bringing GIS data now to the picture. So if you ask me what the official statistics and international organization like UN and the university now we are concentrating, we are trying to bring the GIS to the traditional data now. I'm working on with a colleague from UN, and we are trying to create a new R package, how we can merge and integrate GIS data to the traditional data that we have. And that's an area that maybe the fellow scientists, bachelor students here, they are working. So can I bring the satellite image to the data to see, for example, on the map, looking at my background, you don't know what is the background, the blue and the red and the yellow. You see, that's a wavelength. This is the word that you see in when you go to TV, they talk about prediction. Tomorrow we have, alhamdulillah, we have rain, we are happy. How? 24 hours ahead, they predict. And that's my background image. I'm using this approach in the weather and forecasting of the weather. Now I'm using it for social media, mind reading, and I call it social intelligent mining. And I developed the app for it. And I will share you a little bit of it today. And I will share you a publication, couple of publications is coming about it as well. So it would be fantastic if I can integrate, bring the GIS data, image data, and you see that the network, sensor, transition, all of this, it can be used. It can be used for police. It can be used for hospital. It can be used for policymaker to know. For example, if you want to know on social media to read about who is against or who is in favor of your politician talking, example to that.
You still have time, maybe until about 1 p.m. if you want.
Okay, what about the second speaker?
It will be started about 1:15.
Okay.
Mm.
One means minute-wise. Tell me about a minute.
So you have done about 45 minutes.
Okay.
Yeah.
So then the frequency of our data is quite important because you could have a data on a second, like a Twitter, and believe me, for X, we were using something for Morocco earthquake, and in we look at the 1 hour, we have more than say 20,000-30,000 tweets. So that was very difficult for analysis if you look at it. Then you look at the yearly data, then you look at the monthly data, then you look at the quarterly data. My colleague they are working on time series analysis, they know that the quarterly data doesn't work with the monthly data in a multivariate format in time series. But using machine learning approach, it's changed this approach. And using the AI system, we are changing this. Don't stick with the traditional approach. Learn very well the traditional approach of time series, of statistics, then develop and adapt it with the new data that you have. That's my approach, and that's why I would like everyone looking at it. So, well, I'm by the way, my new paper is coming out about official statistics, how we can use big data. If you look at the name here as my co-author, they are all the head are statistics or UN, and we are working, and we say that the work is about official statistics and the big data. Particularly for SDG. By the way, whatever you do is better you do it for link it to SDG. Well, let me give one example about SDG 1, and then I move to my work, and then I move to my paper, and then we open up Q&A. So there was a team that working on SDG, 9 data scientists working together, looking at the 33,000 employees. They have 1.6 million people data, and then they looking at it to come up with a better data in order to estimate the data that they could use. And looking at the mobile data, you see you have these kind of data, cell phone data, SMS data, the date, the time, who is it from where, the location, if you link this to the GIS data. And then my sister asked about the data previously. You will see that even mobile data provider, they try to eliminate the name, but you like or not, some part of your information will be shared. By the way, data is money. I said data is a new oil, but my definition, data is the king. Now, you can sell it. The information is power. Now, the data is power. Whoever has the data is the most powerful man or woman. Because if you want to say in your country, you want to change the mood of people for the election, you have to play with the data to see who is reacting to what you say. Which part of population, young or elderly? What? Geographical aspect, who in favor of your work. They can gather it from social media. The age of survey, like those that we have traditionally, is eliminating from our wishing list now. So they link the data with satellite data, they link it to survey, they link it to the advanced tool like social network, mobility, top-up, revenue, handset, all of this to come up with the energy and the usage of the poverty as well. I can go on and give you lots of examples on this, but let me share with you something that anyway, at the end, we come up with these tools. But let me share with you the tools that I developed a little bit. I have a few more examples here, but I would like to share with you my work, and then I can show you with one of my publications out of the tools I developed, and then we go for the other part as well. But before I go ahead, if there's any question, please ask me. Any question?
Hello,
No?
participants,
Yes?
do you have any question?
No?
Maybe not yet, Prof.
All right. So let me go to the first part. I developed the tools, which I call it social intelligence mining. I hope that you can see the tools now. Do you see?
Okay, there is one question, Prof, from Galang. He is the first year undergraduate student.
Okay, which one? I have a question. As an undergraduate student, which one is better, learning statistics, become a data scientist, or learning data science, becoming? Well, it's like, to be honest, answering this question, can you answer me first we have an egg or hen? Which one was that? Chicken and egg? Or better to ask, should I be a statistic or data scientist? And I invite you to read my paper about statistic and data scientist. I have a publication on this, and I explained there exactly the boundary between these two, but it goes both ways, you know. You learn when you play with data. You learn when your hand is dirty, as we call it. You learn techniques when you want to explore something, or you have a better information from your data. But at the same time, you don't know which model to use if you don't study them before. So I would say both of them should go together at the same time. Why? If you just read the book, and sitting in lecture like now, and you don't play yourself, you don't learn. And then if you study today playing with data, you don't know anything about technique, how you can use it. So my suggestion is you gather the data, you try to analyze, and then you will have lots of questions. What should I do with this? How can I do this? Then you go and find it theoretically. Then you study sometime theoretically, and then you would say, oh, wow, I can apply this kind of method for myself as well. So I think it's a combination of both, and I would like you fuse them, like I do fusion, and you fuse them as well, then you learn much better to me. But thank you for your question, and I encourage you, the future is yours, don't lose it. Any more question? I'm just checking.
Maybe not yet, Prof.
Okay, my pleasure. So, okay, let me go ahead. Okay, so a couple of years ago, I was thinking about the idea that now we have lots of free available data. Can I use this data? Of course, you can download the data. You can analyze the data. Then, but is there any way that I can link my tools to the data that I can gather? Now we are talking about the subject. And at the same time, this data is freely available. You can use the data that is not freely available, but the best is to use the data that's freely available. Either could be from Google, which is fantastic, like Google Trend. Google give you lots of data. And like X that we can use. Or I can use, say, Reddit, which people now they are using Reddit because it's a little bit free to use, or news. For example, if I want to know, here I put two keywords, which is a food price and energy price. And I can look at it, the country by country, what's going on at the same time, meaning that these topics, what's your country reaction is about. I can look at it worldwide. Even I can go to country like United States, your country, go to a state, to go to city. Which city they are most favored, and they search on this. Which city in the news they mention this, which Twitter, what's the reaction of the people? I can say, go to them, looking at the last day, 7 days, 30, go to back, or 5 years. I can look at the web, I can look at the frequency of that. I can look at the many aspects of these tools. And the maximum of tweets, I can look at the 10, 100, 1,000, million, 10,000. You are easily can do it. So if you look at it, immediately I go to the Twitter, looking at the last 30 days, what would be, it seems that people, food price for them, and energy price. When I look at the last 5 years, that gives you the better view. But when we are talking about the statistics, am I able to look at the map worldwide? Then am I looking at the top countries on doing this? You see, I should be able to look at all of this as well. So if I look at the worldwide, the map, you will see that country like China, for them, it's quite important. You see the energy price. India, it's very sensitive for this country. But in the US and those countries like Saudi, they are producing oil is less sensitive. While I go to food price, look at them. They are much cooler in some part of the world. So immediately you can generate this. Of course, I look at the last 30 days, the data is much less. But if I look at the last 1 month, you will see more activity. But can I say here, if I go to, I can look at here top countries as well. In terms of energy price, you see that the Germany, what the ranking is telling me about food price, what the other countries, you see, you know that the food and inflation is too hot in European, and immediately I can see it here. Now, when I go to the energy price, you see that the country like India, like Singapore, there's more hot about the energy price there. So immediately, for example, you can look at all of this information with the one click. And that's the beauty of data science. I can look at the Twitter, I can look at the other as well information, but then you can look at the what topic they have. You can look at the correlation a little bit. What's the correlate between these two in terms of time lag, in terms of this. But at the same time, I'm looking at the spectrum of these two. What is the spectrum telling me? I bring this here. You see, to me, it's quite important to know if I'm talking about the food price, people they are concerned about food price first or energy price. Which one is leading, which one is lagging? So this kind of analysis is telling me that over the last 30 days, which one comes first, which one goes second, which one is leading, which one is lagging. Let me share this with you, a recent paper which I've written about this as well. Any question now? On the chat I have.
There is another question, Prof.
Yeah. How to create that data map visualization in your presentation? I will show you. Well, we have lots of tools now. Say in R library, you can create a map easily. If you can look at if you want to learn R, which I recommend you to learn, because then you can adapt it yourself. But there are many tools that you can use it, like the map, Power BI. If you want to use it like the ready available map, you can use Power BI, which is more, say, like a modern Excel if you have not used it. But then if you learn to use R, then you can adapt easily yourself. You can program it yourself. You can link to what, like I did, to generate an app like I did. Then you can use your own software. In fact, what I show you, it's my own software, which I developed with the colleagues here, and we are using it for social intelligence mining. And if I show you, it seems that my friend Heiler is here as well. Guten Morgen.
I think he is making a breakfast, Professor.
All right.
Yeah.
Let me share you here. So that's a new paper, which currently is under review. But quickly, I want to show you. I look at the social intelligence mining from Twitter using the same tools that I show you. So let me go. What we did, we look at the earthquake. When we had the earthquake in Morocco, immediately I went we gather the data. Immediately, we link the tools that I show you with the Twitter, and it's linked now anyway. Then I gather those information. It goes and read all the tweets, capture it, says the tweet is positive or negative, the tools, then categorize them. Of course, there is lots of data science formula behind it, but if you look at it, look at the Morocco earthquake that we have, you could look at the keyword, you can look at the, say, what they are telling more. Let me make it smaller, you see it better. And those keywords, what are telling, and then you can, hello? Then we create an index. So if the tweet is negative or positive, what are they talking? What time they are more positive? You see that. What time they are more negative about this? And if they are positive, what they are doing? Do they receive lots of help or no? If they are negative, you are receiving lots of negative. And then if I go to the negative tweet, what are they concerned? Is it the positive is more, negative is more? And then what I can tell about this? But then what we did further, we analyzed, part of it is here, by the way. So what about the frequency? If the earthquake happened in, say, 9 o'clock in the morning, what's happened in 11 o'clock in the morning? Is it the disaster comes first? Is it the help comes first? And you see this arrow that I show you in my tools is giving me the information. What are their concerns? And at the same time, we did network analysis. So about the miracle. So network analysis is telling me that which one is more important, and then let's link the people even they are talking. Who is distributing this? And the information that we are distributing now, the tools, you see it here that I show you just the tiny of it, now is adopted. If there is a information on the social media, is it false information or is it the correct information? Because that's during the disaster, it helped lots of anxiety for people. And with the network analysis, we are able to detect this. So is it disinformation or is it misinformation or is it correct information? And then you might ask, who is using this? Policymaker, those that they are helping during disaster. That's fantastic tools for them, because during disaster, pre-disaster, yearly warning is quite important for people, and after disaster as well. You see that the data science, you create the tools and you can use it lots here and there. And therefore, I can go on and to talk a lot, but I think today I talk lots. So I try to stop here and listen to you if there is any question. I think that's the best to move forward from here. So I have another question here regarding classification of poverty. Yeah. But the first thing that it's quite important to do for the poverty, I did the same tools for United Nations SCAP. In fact, I generated tools based on the data poverty and the data integration. And when you do the data integration in that project, we link the census data to the poverty data that the country is using. And then the social impact data, we link 4 databases, and the data integration gives you the new database that you can use it. The accuracy was high because you could test it. And you know, the beauty of machine learning approach is, even if there are some records that they are not correct, you can correct it and the system will learn That's why we call it machine learning, because the system will learn from the mistake, it improves itself. Therefore, over the time, the accuracy goes higher and higher by learning. And that's why we said the machine learning. That's a basic, in fact, definition for machine learning. So the accuracy was quite good. And of course, depends on the data. We did lots of data cleaning, and data cleaning is one of the most important part of your work. The paper that I just shared with you, we spent lots of time on data cleaning, because you see, when there is one tweet, the other will just retweet it. So you need to eliminate the retweets, and assume that I give you 10,000 tweets. It takes you maybe a week, 2 weeks to come up with the good and clean data. But when you use statistics, machine learning, and technology, is much easier for you to do it. That's why I encourage you to learn your own algorithm, Python, or any other language you would like to learn. I'm looking at if there is any more question. I'm happy to answer. What I would encourage you to look at my LinkedIn and link with me. I publish lots of my work now. I'm on LinkedIn. In fact, that's why we know each other. And I already, one of the students here linked with me. With pleasure, I accepted you. So you can read my new work, and then we can be link and share the information together. So link with me. There are many Hossein Hassani, and LinkedIn try to have a correct version of me here. So that's why it's much easier to be linked and to talk and then follow my work too. That's why make your research more impactful. And I'm sharing again here my profile with the QR and ad, so you can easily scan the code and you to my LinkedIn. And looking at my recent thing, which is about Bitcoin energy consumption. In fact, I wanted to tell you this. Let me look at your country compared to Bitcoin energy consumption. In fact, interesting. Your energy consumption is more than Bitcoin in total, but is only 50%. So meaning that if we stop today Bitcoin in the world, you have 50% more energy consumption. And believe me, 85% of the world countries' energy consumption is Bitcoin is much higher than that. So this is what you can extract from the data. So that's another concern for the technology. The technology is here helping us a lot, but at the same time is consuming our energy and electricity, sometimes unnecessary. But we have energy poverty in many parts of the world, but unfortunately, we don't look at it. Prime example is the area that you are, and also the African countries. So back to you.
Okay, so is there any other question? No?
Yes, there is another one. As a beginner, since
Okay.
you were in expert statistics, what should we do to become successful data scientists in future? Well, Faiz, if I have your name pronounced it correctly, you should love data. I'm data lover. That's the first thing. So the love is the most powerful thing in the world, and that gives you the energy and power. The good thing is what you are studying now is the current and contemporary issue of the world and gives you more power. Everybody looking at data scientists. The data scientists, they have a special place everywhere now. And to become a successful data scientist, you need to learn, you need to use the data much better, and you need to find the application of the data. And it's a journey that every day you learn something new. And I encourage you to produce your even small bit, your code, your programming, or your software, the result, the way that you would like to do, because that helps you to learn more. At the same time, you enjoy from what you produce. And that's the best thing, because now I show you the tools that I developed as an app, and these tools is more useful now, you see? So when you produce this, you enjoy that. And when you publish and you see the people, they are reading, they are reacting based on what you have produced, and they are using it, is a joy. This joy helps you to grow. And if you love what you are doing, that's the best thing. In 1996, when I started data science, statistic that time, the statistic was only those that they have a census. So no covered like this. Now, statistic or data science is fantastic. That time was not. But there was a professor who told me that time, he told me that in future, data science and the statistic would be the world leading. And now I understand what he said. And now I encourage you to do that. And as a bachelor students, you all have a golden opportunity. Everything that you learn now, you will use it in future. And that's for sure.
Okay, thank you, Prof. The student who asked you the question in here, this is undergraduate student, and they are from international program of our department. So I think that's why they are really want to know more about statistics and also about data science, because your background is actually statistics, but now you are becoming data scientist. I think maybe in the future, if we have a collaboration work about workshop or short course, maybe they will be eager to be the participant of that event. Okay?
Yeah, sure. It would be my pleasure.
Yeah. They can learn a lot. We also can learn a lot from you, because your background is statistics, but you are becoming a successful data scientist.
I'm still a statistician, by the way. I'm still a statistician, and data science is a statistic anyway. So I don't distinguish these two. And
Okay.
that's why I said, read my paper. I said, is it data science or statistics? The backbone is the statistics anyway. The backbone of all of this is data. Without data, there is no data science. Without
Mhm.
data, there is no machine learning. Without data, there is no
Mhm.
AI. And
Okay. Right.
statistics is a backbone of all of this, because
Mhm.
a statistic is teaching us how we can gather the data, how we can
Mhm.
store, how we can filter, how we can pre-process and prepare to be used for modeling.
Mhm.
We learn modeling
Mm.
from the day one that we learn statistics. And therefore,
Mhm.
we have a different name now, data science, because we bring the element of technology to it as well, like I did.
Mhm.
Now I'm using AI,
Okay.
now I'm using tools, the app, the software that I show you, I develop myself. Therefore,
Mhm.
I don't call, I have a title about data science, the dude, but that's the name. But the core is the same. I consider myself a statistician. So sometimes I hear that even the professor in the statistics department who was offensive
Mhm.
about data science, he said, "Are we a statistician? Tell me, or you are data scientist." I said, they are the same, you know. The, what's the data science? In fact, I wanted to have a slide. Data science, we have a statistic, we have an AI, we have a technology, and the middle is data scientist. But to me, the backbone, as I show you here, and majority of my talk is
Mhm.
about data. And then
Mm.
those other are the algorithm. I can collaborate, I can show you how we can use the machine learning and AI to come up with a better forecast, or for example, the poverty
Mhm.
rate. But I can use the forecasting tools in order to come up with the
Mhm.
forecasting. And
Okay.
we can use the clustering method, we can use the classification, we can use the
Mhm.
text mining and the web mining. The application that I show you, we have a web mining on it,
Mhm.
we have a text mining on it, and we have
Mhm.
a data mining on it. You see, and I really, please read my publication, and I have all of this: web mining, text mining, web mining,
Mhm.
and data mining. So in the
Okay.
application that I show you, we have all of this. The tools
Okay.
goes to web, goes to Twitter, goes to news, goes to Google, read all the data, but at the same time, it read them, it translate them to positive or negative. So it's a text mining. So you need to mine the text
Mhm.
and then analyze the data like I did it for you, like a wavelet. Which one is leading, which one is lagging, and which one is noise, and which one is news. These are our
Mhm.
statistics. And then we
Mhm.
provide them to the next level.
Mhm. Yeah. Okay. So I think we are coming to the end of this session. Thank you very much, Professor Hassani. We were very grateful to have you today. And I hope that we can have a collaboration for the short course or workshop. So for today, it is like introduction about AI, data science, and the others. But maybe another time it will be more deep into AI or machine learning or something else. Okay. So once again, we can give applause to Professor Hassani.
Thank you.
Okay.
Thank you very much, and thank you for having me. The last word from myself. The future is yours. You are tomorrow leader. And when I'm teaching my undergraduate students, I'm looking at them that when I'm retired, when I'm old, sitting in home in front of TV, they are the one that decide for myself. They are the one that decide for countries. They are the one that became head of department. They are the one that my children goes to a school. So it's better I treat them very well, because now I'm in a role that I can say yes or no, but tomorrow they are the one that they tell us yes or no.
Exactly.
So it's good that I teach them very well. It's good that I treat them very well, because tomorrow they treat me as a person in that society. So to my undergraduate students, future is yours. I'm happy, and I'm sure my friends and colleagues, they are there. We are grateful to serve you. We are grateful to teach you, and we are preparing you for tomorrow. So enjoy the moment, and learn more, and challenge us to teach you more, because you are the one that to build up the country. And all the best to you, and inshallah you will be a good leader.
Amen. Thank you. Thank you very much again, Professor. And we also now already have the second speaker, which is Professor Heiler. You are both from Austria.
Yes, I'm leaving the session, but I would like to thank you, my fellow from Austria as well, and then Guten Morgen to him as well. And all the best.
Okay, thank you very much, Prof. Bye. See you another time. And now I think, we are coming for the break about maybe 10 minutes. And then after that, we will following the presentation from Professor Heiler. Is that correct, Mbak Zahra?
Yes, Ms. Emma. We will have a break first.
Okay, so Professor Heiler, we will have a break about 10 minutes, and then we will have you after this, okay?
Yes, this sounds great. Can you just briefly check the screen that everything works smoothly later?
Yeah, okay. You can cooperate with Mbak Zahra. Mbak Zahra, could you make like the, for example, the sharing screen and the others? Can you try now?
Yes.
Yeah.
Can you see my screen here?
Yeah, we already seen that. So
you see it already?
Yeah. We will have a break because we didn't do the Zuhr praying. Just 10 minutes, okay?
That's fine.
Thank you.
Dawn again greets us beautifully. A bright and glorious future gives us happiness and perfection. We, the Master Program in Statistics UII, are founded to produce globally competitive graduates in analyzing data and statistical science advancement. The Master Program in Statistical UII is one of the master programs at UII, which focuses on business, industry, social, and actuarial, data science, spatial, and bioinformatics. We first established on September 21st, 2022. We provide education according to national standards that are globally oriented, such that graduates can play a role at the national and global levels. The Master Program in Statistics UII is a pioneer educational institution that prepares its graduates to become experts in data analysis and integrating the MBKM program. We are located in Professor Dr. Haji Zanzawi Suyuti Building, Yogyakarta Spatial Region. The Master Program in Statistics UII works confidently, has a strong commitment, and is supported by competent human resources, up-to-date facilities and technology, extensive network partners, experienced and accredited by Ban PT Higher Education. The Master Program in Statistics UII aspires to become excellent in data analytics and the development of statistical knowledge to advance science and technology through teaching, multidisciplinary research, graduates who are competent, flexible, innovative, and have excellence in Islamic principles. The learning outcomes of the master's program in statistics are summarized into creative minds, namely excellence in communication, producing outstanding research, professional entrepreneurs, strong analysis skills, up to date with technology, having Islamic ethics, understanding of differences, responsible elaboration, managerial data skills, creative in innovation, proud to be Indonesian, having diagnostic abilities, and leading in science. To provide the best service for students, the Master's Program in Statistics UII provides international standard laboratories to support the learning process and research activities. They are Risk and Disaster Management Statistics Laboratory, Business, Industrial, and Social Statistics Laboratory, Data Science Statistics Laboratory. Various campus facilities at the Master's Program in Statistics UII are provided for students to get the best experience in studying and doing activities during their studies in UII. We are committed sustainably to developing and improving the service to provide the best educational services. We strive to create a new future through innovation, research, and passion that benefits all humankind. Wherever you are, come and join us and be the best partner of life.
Imagine this. Your future university is the pioneer of higher education institutions in Indonesia. An Islamic university that welcomes all interested citizens, a place where you will learn the beauty of diversity while still faithfully adhering to Islamic values. Imagine this. You are able to experience international education in an international university with global recognition. Study programs are accredited and certified by various countries such as Japan, Korea, England, and the USA. A place where you explore science through 8 faculties and 48 study programs that you can choose from. Where you can weave your dreams while enjoying collaborative adventures with global scientists. And broadening your horizon through national and international partnership programs. Imagine this. You can pursue higher education in Indonesia in a private university that has a lush and green environment. An excellent university that is tirelessly innovating in various fields. A place where you can learn freely, whether surrounded by calming trees or inside the buildings, online or offline, beyond the classrooms, unbound by distance and space. All is provided to nurture you to become an active and innovative generation with diverse perspectives, which in turn earns appreciation. Imagine this, your future university supporting you to become an intellectual who is not only academically profound, but also spiritually insightful. The best private university that still strongly believes in academic freedom, encouraging you to express yourself in an era of fierce competition where contributions to problem solving are much needed. Its academic staff, as well as 107,000 alumni, have proven their worth, becoming Ulil Albab who are able to integrate science and Islamic teachings for the development of various sciences. Imagine this, your university is located in Indonesia's very own city of education, a city with a wide diversity of stories and cultures waiting to be discovered. Universitas Islam Indonesia is a university that is truly Indonesian, standing side by side with science, culture and art, creating a harmony of beautiful colors. Now stop imagining. It's time to realize your aspirations. Are you ready? Because here at UII, we are ready to show you the way.
Well, ladies and gentlemen, since it's already 10 minutes after break, so I think we can continue our event right now. But before we continue our webinar, we will have first a photo session for documentation with Prof. Heiler. So for all participants, please turn the camera on and use the background image that has been given by the committee in the chat column. Once again, we will have photo session with Prof. Heiler. So for all participants, please turn the camera on and use the background image that has been given by the committee in the chat column. We will wait. Okay, I think we can start the photo session. Count in me. 1, 2, 3. Okay, once again, 1, 2, 3. Okay, thank you. Now we will continue to the webinar from Prof. Heiler, and the session will be moderated by Mrs. Emma. So to Ms. Emma, the screen is yours.
Great. Let me briefly check the audio and the screen. Can you nicely hear and see me and my screen that is shared?
Yeah, we can hear that.
Great. And you can see also the screen moving if I click something or zoom in and highlight stuff, right?
Yeah.
Awesome. Then let's dive right in. So for me, good morning. For you, I get it's around lunchtime. Greetings from Austria. I'm Georg, or Georg Heiler, as we would say in the native language. And today I will talk about geospatial statistics and give a brief introduction to the topic. I already shared with Emma, I would like to make this talk interactive, if you want it to be interactive. So please ask questions during the talk, not only after. And maybe you can moderate these questions, because I will not be able to look at the chat all the time because I'm focused on my screen share. So please stop me in case there are some questions in the chat and raise them. Briefly about myself. If you want to learn more about me, please take a look at my shared LinkedIn and also webpage. I have co-founded some startups in the past. Right now, I'm a senior software engineer with a specialization in data handling in the industry about telecommunications. Have been lecturing a couple of times at UII. In fact, I was there already once in person. I'm looking forward to join you now as COVID is gone. And I'm very active in the local data science community in Austria, organizing various meetups around data science and data engineering. And I'm also a postdoc researcher at the University Complexity Science Hub in TU Wien. A brief agenda for today. I want to start with the properties of spatial data and give you some typical examples what spatial data might be or how it could look like. Talk about various spatial use cases, about how to work in particular with vector data, because this is a very common source for a lot of people. And then look into how you can scale this to larger data sets or faster analysis. And then move forward, if we have enough time, to give you a brief introduction about some geostatistical methods. So what is geoprocessing? The idea is that it's basically about operations to manipulate spatial data and to find or study specific interesting phenomena. That can include overlaying of various geographic data sets, selecting, analyzing, and also topologically processing these data sets, not only on the vector side, but also from raster files, and converting various data formats. Furthermore, geospatial statistics is basically statistics with spatio-temporal data, so data in the domain of space, time, but usually also some topological component is relevant. Like in Google Maps, the route that you're allowed to take might be restricted. Geography matters, and a large quantity of data is actually spatial. Some people say 80%, according to recent research, it's 60%. In any case, the amount is huge. So I guess we should be more interested in processing spatial data and in learning how to do that. What are properties of spatial data? I think in the first talk we have already seen some of them, but let's dive in. In general, you have some kind of spatial reference. Here in this particular example, you have a WKT reference to various polygon geometries. Usually, these geometries could be various shapes like points, polygons, lines, either one-dimensional or two-dimensional, at least from a traditional perspective. Recently, with self-driving cars and LiDAR scans becoming more widely available, these tend to become three-dimensional or four-dimensional point clouds that describe the world as machines see them. Usually, a latitude and longitude as an x or y coordinate can be extracted somehow from these geometries, when additional attributes are measured within this space-time raster where the data was collected. What is latitude and longitude? Basically the two axes of the Earth to describe where you are based on the coordinate system. And as the Earth is more or less round, not fully round, there will be some, let's say, inconsistencies, in particular in various areas. This is why choosing the right coordinate system is very important. As you saw in the previous picture, the Earth is not a perfect sphere, but it can be approximated by some ellipsoid. So we need also a reference coordinate system based on this ellipsoid. Widely used one is WGS 84. It's in fact used by the GPS system, and it has in general minimal positioning error on the surface. However, it's not suited for all applications. As you can see here on the left side, you see the globe. On the right side, you can see basically the unfolded map version of the world. For some applications, it's more important that there's no distortion. For some, maybe a local distance should be consistent on various places of the world map in order to calculate distances properly. For others, preserving areas is more important. So as we see on the next slide, there are multiple ways how you can basically unfold the same data, or we call it multiple projections. And depending on the use case or on how you want to work with the data, you have to choose a suitable one. Oftentimes, if you're not working with global data sets, choosing a local or Euclidean projection makes a lot of sense. Because it makes it simple within your local, let's say, country to compare distances. Some common two-dimensional projections can be cylindrical, conical, or azimuthal, and that has some implications on how the data is basically displayed. Every variant of these has a trade-off. Some are length preserving, some area preserving, some angle preserving. And depending on what you need, you basically have to choose a suitable one. Me being currently in Austria, I can tell you here in Austria, the equal area one is the MGI for Austria in Lampert. And that is used here, but also the Albus one in the States quite frequently, besides the basic one, the WGS 84. It's important to remember that there are different coordinate systems, and that the data sources that you might be working with could also be unique coordinate systems, different one for each. So when processing or cleaning data, as also discussed in the first talk, really make sure that you understand the source data you're working with, and that you understand the projection it is coming in, and only then you will be able to align them properly to a single harmonized projection, so you can later then overlay or compare the data sets in a semantically actually meaningful way. Geospatial data comes in many data formats. In fact, I think this is a domain where the various, let's say, formats are so the difference between the formats is quite big. In particular, there are, let's say, three major categories, and one is basically vector data that is already easy to process for, let's say, people with a traditional database, data science, computer science background, because it sort of behaves a little bit like a traditional database with some additional spatial flavor. And this would be well-known text, GeoJSON, shapefiles, geodatabases, points, and GeoParquet files, if you're working with more modern files. On the other side, very large data sets, in particular satellite data, usually comes in raster, basically image-like shapes. Where a popular format could be GeoTIFF, but there are a lot of image formats that have some spatial characteristics baked into them. Last but not least, there's the LiDAR data as a different additional format, which is very large in size. What is the difference between these, in particular, let's say, traditional vector and raster applications? Basically, the vector is something you can zoom in as much as you like and will not pixel up. And that is nice for display, nice for, let's say, simple processing by normal non-GIS specialists. On the other side, it can, for specific applications, also be more efficient to work in the raster domain. What types of geometries are there? As already mentioned, there are a couple of basic geometric building blocks. Points, line strings, and polygons, that are very common. But there are some more, let's say, combined ways of representing data, where there are multi-points, so within one, let's say, line string of a WKT text, you can have two or multiple geometries. In fact, not only points, but also lines and polygons. This allows you to craft complex polygons, in particular ones with holes and more fancy geometries. As you have seen before, data might come in various file formats. In order to conveniently process it, you do not only have to align the coordinate system, but also you will have to align basically the data formats. The OGR2 OGR tool is a very common one that allows you basically to convert the data sets. In fact, not only conversion, but also processing of the data is possible there. It has many connectors to various systems based on GDAL and the fundamental underlying geospatial processing ecosystem. If you want to get more complex in the cleanup and pre-processing section of your pipeline, you will want to resort to custom code instead of only working with bash scripting. There, you might want to look into Python. It has very good spatial extensions. Same goes also for R. And last but not least, for very large-scale applications with very large datasets, you may also want to explore the JVM for more, let's say, robust production pipeline potentially. But in recent years, the ecosystem has improved a lot. Still, if you have some specific low latency use cases, maybe rewriting certain algorithms in Rust could be also an option. Usually not an option for most people. With that, I want to come to some examples of spatial data sets. I think one of the most common examples actually is GIS, in the sense of Geospatial Information System, where in particular governments are publishing open data sets, where you have geomarketing use cases, and you have not raster in the sense of raster data sets, that is an image, but usually you get various, let's say, subgroups of a country, be it by coastal codes, political regions, and or mathematical well-defined raster like S3, H3, GeoHash, that allows you to overlay specific dimensions, like shown here, maybe buildings, vegetation, and so on, to get an integrated overview of your surroundings to analyze maybe, let's say, demographic discrepancies or other topics. That is commonly used. And a lot of these geospatial visualization tools like ArcGIS or QGIS actually are well suited for this case. A second
George, we have 2 questions in here. If you want to, So the first one is from Galang. He is international program student. What is data science aspect in spatial statistics? That's the first question. And the second one, could you explain some research on spatial statistics application?
So for the second one, I want to defer it because some use cases or examples will come in a couple of slides, so very soon, regarding what is the data science component in spatial statistics. I think the previous speaker already mentioned, let's say, data science is similar to statistics, or if not the modern word for statistics. So basically, geospatial statistics is sort of, or geospatial data science is sort of very much related. So it is basically baked in from the start. But if you want to be a bit nitpicky, it is sort of traditional statistics in a geospatial domain, or traditional data science in a geospatial domain, with, let's say, added complexity of this particular domain.
Okay.
I hope this is answering the question. Otherwise, please follow up for more details.
Okay, thank you.
Another source of data could be GPS data. GPS in the traditional sense of actually GPS, that is quite accurate, or in the broader sense of some sensor providing latitude, longitude measurements. For example, if you have smartphones and you locate them using the phone network, for example, by triangulation or other means, where you don't get maybe the highest accuracy of location. Furthermore, there is some actually research field about remote sensing, where the idea is to process satellite data, usually to track how the Earth is changing over time, like tracking, for example, deforestation, looking into, let's say, insurance cases, there has been some devastation, and then people are claiming claims that are real or maybe are not real, and they want to really check, did this happen? And yeah, it was about forecasting the future, about weather analysis. Like Google in particular recently raised a new paper about geospatial deep learning and how they basically fused a lot of sources of data to improve there. Further sources of data, actually streaming data in the sense of real-time IoT sensor data that might have, in fact, a geospatial domain. One example I could really relate to with my telecommunication background could be, let's say, a sensor measurement of our cell towers. They all consume energy, they all have a certain, let's say, workload to carry. Now we want to optimize this and save energy. This could be such a case here. Furthermore, there's the LiDAR scans, where it is a three-dimensional scan of the surroundings. It can turn into sort of a video stream when you're moving around to better understand the surroundings. And it is used for a lot of, let's say, self-driving cars, for drones or maintenance of industry plants, or perhaps drones that are flying by industry plants and checking if there's some maintenance needed. So let's say power lines, checking the poles if there's some maintenance needed. One more data set is actually topological spatial data. What is the topology here? Basically, it's the connectedness of points. As you can see on the map, there may be many streets, but some have a higher weight to connect them in the sense of longer travel time, or maybe a fee that you have to pay. And others are don't allow me to turn maybe left or don't go in one direction. And you have to basically obey the topology to go from A to B. This is or can be important for various spatial analysis, particularly if you want to analyze, for example, travel times between one location and another one. Maybe there's a river between 2 points, and they could be quite close actually from a Euclidean distance, but the distance on the road network might be a very much different one and potentially much longer. What are spatial use cases? I think we heard one before already about disaster recovery. The idea is to, by looking at these large satellite data sets, get some awareness, potentially mitigate these attacks by evacuating people, and then aid in the recovery process. Another one is urban planning. There, the goal would be to understand perhaps where it's a good place to put new streets, new buildings to cater for an overall very livable city. Very important one, and increasingly important one, is in fact precision farming in agriculture, where the farming devices are more and more automated or maybe improved based on individualized farming, and then they sense perhaps drones flying over the crops, what is needed in particular areas, and change the amount of fertilizer per, let's say, square meter individually. Another use case is in fact geospatial processing telecommunications for various use cases. One is in fact, let's say, network optimization, where you want to analyze the traffic in specific areas of the field. A traditional case would be identification of crossed feeders, basically where the cables have been miscabled. Instead of looking to the left side, the signal will look to the opposite direction and not reach the city, but maybe the mountain. Signal coverage, performance analysis along railway tracks, for example, analysis of network coverage, and then also footfall analytics. I see one question in the chat because I have it open now. What programming language do we need to learn? Do we need to learn Linux as well? That depends on what you want to do. It is always good to learn also Linux, but you're not limited to using Linux. So if you want to use a Mac or you want to use Windows, you have actually, let's say, maybe sometimes a harder time, but it works as well. And regarding what you should learn, what language in general, Python is a really great language. And in particular, if you're on Windows, you might want to use Anaconda, or in fact, I prefer Miniconda to set up your own version of Python for this particular project with a particular Python dependencies on an as-needed basis, so you don't have any clashing dependencies. Python is a very strong language for geospatial processing and also good for start. If you realize you need some more special applications like embedded devices or very large-scale analysis, you will by then already be, I guess, a proficient expert of Python, when you should not have a hard time learning maybe Rust or maybe Scala. Last but not least, one of the big cases in telcos is also footfall analytics, particularly, let's say, during COVID, because all of you have seen how phone analytics were used to figure out where people are going and perhaps use this to improve on forecasting. There are more use cases about trip analysis. For example, at Uber, people are, or the company is really interested to know what do trips look like. How can we reduce the wait time between for the people that want to have a trip? And are there some new products that people might want to have? A lot of people usually consume open source projects. Some companies also create them. Uber created quite a lot of geospatial projects. One is in fact H3. And I want to explicitly point it out here, because H3 is a special type of spatial index that is very efficient and always good to know to keep in your head and perhaps use it in your analysis. And they also created various tools here, most importantly, Kepler.gl, where you can easily create stunning visualizations, but also they have some good visualization experts for more advanced self-driving car simulators, plus some nice dashboards. And I quickly want to show you perhaps how Kepler can look like for some sample data set. For example, here we have a flights data set. And you can, as you see here also on my screen, in, I guess, real time, basically with a couple of clicks, load the data and create impressive visualizations, which are usually much nicer than what the traditional geospatial visualizations tools provide out of the box, and also easier to create. And you can easily animate them and see how these flights are sort of changing over time. And it also should have some 3D option where you can really see how stuff is when moving around. So this is, I think, a very good tool to keep in your head and be aware of. One more use case is, in fact, traffic jam prediction based on GPS data or floating car data, where you would want to estimate the speed of cars on the road over time and compare the maximum allowed speed and the speed that usually is there on that particular road segment with the current speed. And then we'll be able to identify traffic jam data. And you will be able to do something like Google Maps, where you can then highlight traffic jams if they take place. This example here was calculated using a Spark SQL and a Zeppelin notebook, but you could do something similar in your tool of choice. One more example that is very, let's say, important to me, because it was also part of my PhD defense, was looking into large-scale geospatial phone analysis in Austria during COVID. And we were basically tracking how the devices move. Here you can see an origin-destination matrix, and what you can basically see is how it drastically is decreasing the mobility between the regions, and all of this integrating into a couple of big city hubs during the lockdown restrictions. We were able to do but much more than only looking at origin destination matrices. When computing spatial statistics and then comparing it per cohorts, in this case gender, we can figure out that, for example, the females drop their mobility much more than the males, and in particular, as the lockdown is increased and in fact males start to work again, females are maybe more at home and taking care of the family. And it can also be used to analyze inequality between these cohorts. just as a nice addition, we were, when contrasting with calls interactions of these genders, and we were seeing a spike between female-female interactions, which might be mother-daughter interactions. It was much more than the male ones. With that being said, let's dive into spatial analytics. Traditional data science statistics is usually concerned about connecting data sets and then deriving insights from it. The more data you can connect, the more interesting insights you can create. Traditionally, you basically combine data sets in these ways, where you basically combine them with attributes match, or if they don't match, and you get a couple of various set intersections. In the spatial domain, this is also possible. So the same operations you just saw are possible based on the attributes. However, for the particular spatial fields, you have some more options. You can check that the geometry is basically overlaying in various ways. It's the difference, it's the intersection, or you can clip, erase, and also split geometry up. These are the basic spatial operations. And this can be done using various scripting languages, like Python, for example, like the OGR to OGR tools with their analytical capabilities, but you can also work with databases. Databases tend to have advantage that if more than one person should be able to interact with the data, they provide already a lot of features around, let's say, concurrency, transaction handling, and so on, but also scalability to make it easy to collaborate on the data and to share it. One system that most of you might know is, in fact, Oracle. It has some spatial extensions, but Postgres in the open source domain is much more convenient to use, and it has also spatial extensions which are, in my opinion, even better than the ones that Oracle is providing, and certainly much more flexible. It has further extensions for specific spatial analysis tasks like routing and trip analysis, as we will see in a couple of seconds. How does spatial SQL look like? It looks very similar to traditional non-spatial SQL commands, but with spatial enhancements. So here, for example, we have the st contains operator that is checking if some specific geometries are overlapping. There are many more spatial operators, but I think it can serve well as an example, only look at one. How would you traditionally potentially speed up queries in a database? And also why this might not be enough, as we will see later. You would traditionally create an index. So this means in the spatial domain, you would create a spatial index. This traditional spatial indices, in fact, are usually around these tree-based approaches, where you partition the data set and then have a quick lookup to the regions. Why might this not be enough? Well, if you have very large-scale data sets, these tree structures, and building them on a single compute node can be very limiting. And there are some other approaches, in particular with hexagonized tiling of H3, can be a very, very efficient means to efficiently handle large-scale data sets. What are other operations that these spatial databases might provide for you? I think the first talk already mentioned clustering. So in the case of PostGIS, there's a st_cluster dbScan, which is basically finding connected points in connected groups of points in the data sets. And then you can basically derive these groups from the data using these, let's call it, statistical methods. I don't like the term AI because this is, let's say, rather well defined. And then you could analyze these groups individually and then assign semantics to them and figure out perhaps that some of them are more wealthy than others or have different conditions of living based on the attributes that you can join from other data sets. As said, Sportscrest does offer a big, let's say, potential for add-ons in the domain of geospatial. There are two that should be mentioned. One is MobilityDB. It's a fairly new add-on, actually. It's built around trip analysis. So if you want to analyze how things, people, phones, that's maybe even containers are moving around the world, how they can be then basically compacted to trips, and when you have trip chains and stays and how this can be analyzed easily, then definitely take a look at MobilityDB. If you're interested in calculating isochrones, so basically the distance that people can move within a given time frame, you do need to work with topological data. You do need to work with a road network, and there PG routing is a really good software. What are some further tools to work with the data? GeoPandas is a really convenient tool in working with spatial data from Python. And there are many more options, as you can see in the list. Depending on what your background is, there will be some integration from your, let's say, favorite tool. But for vector data, GeoPandas is really great. For some spatial analytical tasks, Spatial is a good option. And if you're looking into the domain of vector data processing, X-ray should be something that you're using. Traditional spatial visualization can be super creative, but it should also be efficient. So you don't want to hand code the visualization, but in some cases this might make a lot of sense. Nonetheless, there are some established tools to make it efficient. First and foremost, I want to name QGIS. It's an open source GIS system where you can overlay various spatial data layers, and you have a plethora of tools available to process the data. There is also ArcGIS as a commercial option. And then there are various other tools in the list, in particular traditional BI tools. So if you don't only need some basic analysis and you have some BI tool that should serve you well, but if you want to do complex spatial analytical tasks, we look into these first two options. Mapbox is JavaScript based. So if you build custom JavaScript based with analytical applications, Mapbox could be a go-to option for you. Kato has a nice, let's say, data science friendly, notebook friendly integration for data processing. Basically, we're wrapping Jupyter notebooks, PostGIS with some pre-prepared data sources in a neat way. And if you want to share and expose geospatial data to other people, these WMF or WPS services via GeoServer could be a good option. If you are simply a data scientist and quickly want to visualize spatial data set, look into Kepler.gl as shown before. It is, I think, in my opinion, one of the most powerful and efficient ways to analyze spatial data sets from a visual perspective. It's also one of the most easy ones to get started with. What are common analytical tasks? Clustering points in space, analyzing watersheds, so how the water is flowing to perhaps understand if specific villages might be impacted if a dam is breaking or if there's a rainfall. Interpolating data, creating data, detecting patterns, and also forecasting on a geospatial domain. So this is all nice, the tools and the spatial data we have talked about, but in recent years, data started to become larger and larger. And people figured out running the analysis on their laptop on a single server were not enough. And they figured this needs to be scaled. And in recent years, when looking back in history, has been around 2008, 2012, people, that was Yahoo, Google, and the big internet companies figured they need to scale up their processing instead of they need to scale out instead of scaling only up. because basically the I/O can only be increased if you have more machines, and it can also only that can increase the reliability of the whole system. This was the case for non-spatial data, but for spatial data, which is huge when you're looking at satellites, it is arriving very fast when you're looking at IoT sensors, you even more may need these scaling capabilities. The MapReduce paradigm that was built is serving traditional data analysis well. However, you need to include some spatial primitives and spatial integrations to not make people lose the convenience of something like PostGIS. Only in very recent years, this has been included in common large-scale data processing solutions. The MapReduce paradigm, basically, the idea, assuming you have a file with words, and you want to basically count how often each word occurs in this file, you would map the data set to tokens, to individual words, then make sure that one type of word always goes into one computer, you shuffle it and exchange the data when you count the individual words on various distributed nodes, and in the end you reduce and combine it and sum it all up, and then deliver the final result. And that is very scalable, very robust, but you must not forget the ease of use. In recent years, much more tooling has spread around the scalable data processing, usually also around Python, because MapReduce traditionally was developed in Java and was very, let's say, clumsy to work with and also quite complex. Furthermore, the hardware changed. Nowadays, we can easily buy or rent computers with 6 terabytes of RAM. So what some people in the past were required to use a different distributed system, today maybe can be run on a single machine. And in particular, DuckDB is very powerful and easy to use. And I have seen many use cases where DuckDB was outperforming R by, let's say, many orders of magnitude in speed, but also in memory what was needed. And it's by far simpler to use than, let's say, Spark or Dask as more, say, distributed systems. In any case, there are tools available to make your data processing scale, and some of them also have geospatial options to make geospatial data processing scale. I think most interestingly is DuckDB, because it is easy to use and as sort of resembles PostGIS as an analytical data warehouse for geospatial data, and serves well for most data sets. If you have to scale more, when looking into Dask or perhaps Spark is an option, depending on the size of the data sets you're working with. There is much more complexity with large-scale geospatial data handling, but in very short, it's in particular about the spatial joins, about how to exchange these spatial data sets that is usually prone to hotspotting, where maybe there's much more data in cities than on rural areas, and how to split the load in an efficient way across multiple machines to not overload one. Traditional tooling started to code up only very recently. So PostGIS in 2017 started to introduce parallel joins to do a first step towards optimizing performance. Also, ArcGIS was very slow in offering that, actually. But as of 2023, not 24, cloud data warehouses like Snowflake and BigQuery, in fact, offer a lot of geospatial functionality out of the box. So you don't need to choose a different tool. And in the case of Spark, Sedona is available. I also want to shout out to Sedona, because many people are using Spark for data science projects. So Apache Sedona is an integration, in particular to Spark, and it delivers a stunning list of spatial functions. You don't need to develop them yourself. You can directly tap into them. Sometimes, however, that is not enough, and you need to develop your own. In particular, if you want to work with, let's say, edge cases, you will always have to understand the fundamental primitives, and when you should be able to mix and match. Here in this particular example, you have to understand that when you want to perform a join in a distributed system, there are two modes how you can do this. Basically, you can combine two big data sets and you have to exchange them and all of the pieces between the nodes. That can be a very slow process, as network connectivity might be limiting. However, if you have one small data set, what if you can push the small data set to the compute nodes and then process it inline? And actually, it's possible to do similar things with spatial data sets. You could create a spatial index on the master node of the system, on the driver in the case of Spark, and then move it to the other nodes and then apply the spatial operations inline for the small data set and compare to the big one. So even if maybe tools are not offering out of the box what you want, even if you understand the fundamentals, you are able to mix and match on an as-needed basis, and that can become very powerful. Here's a list of things that can help you scale your data processing. In particular, GeoMesa and Apache Sodona are very notable options here. Also, when you're working with GPUs, looking at the Rapids AI ecosystem can be a big opportunity to speed up your analysis. However, it requires to have access to GPUs, and in the age of LLMs, that tends to be scarce. To conclude the talk, as a last chapter, I want to briefly also look into geostatistics and give you a short overview here. One important measure is spatial autocorrelation, or Moran's I, that identifies spatial dependence. And the idea is that phenomena that are close to another in space are more likely to have similar characteristics than those that are further apart. Let's say communities in a city tend to be more similar within the community than outside to the next community. And here the idea is projected to the spatial domain. This is an important, let's say, geostatistical function, but it's quite, let's say, as you can see in the formula, compute intensive. There are many, let's say, nested loops that need to be executed. So it's also, let's say, computationally very expensive function to calculate. If you want to scale such computations, understanding spatial indices, using them efficiently, and perhaps also understanding what raster data like these hexagons of H3 indices can offer is really important to maybe approximate such functions at scale. What we will see later is you can even use deep learning operators to speed this up. I see one question in the chat. Are references to data sources related to spatial data, especially those related to population mobility? So as shared before, like usually there are GPS data sets and phone data sets, and there are various data providers where you can get them from. It depends usually on your country, if you or the location of interest where you can get them from, but that is usually available and you can buy it somewhere, or you can collect it. For undergraduate students, starting from which topics should we study related to spatial statistics? So where should you start? I think starting to look into GeoPandas is something where you should start. That is, I think, a very useful tool to have. But I want to give you more in-depth answer, and that is, I have like a lot of links in my slides in the backup. And I will share these slides with UII so they can redistribute them to you all here in this call. And as you will see, these links include a lot of further information and great tools and tutorials on how to work with spatial data. So I would recommend you to take a look there. The next question was, how long should we learn about big data technology related for spatial data sets? That is hard to say. I think you learn the most efficient way if you use it for a concrete problem, or if you learn on the job, because otherwise it can be sometimes superficial. And as said, modern cloud databases like BigQuery, like Snowflake, do offer integrated spatial processing by now. So depending on what tools you're using, you may or may not need to understand so much about the fundamental primitives and basics. You can simply apply the operations there. So how much should you learn, or how long should you learn? That is a good question. It depends on what you need. But I think you should first and foremost start with the simple tools and then make things more complex on an as-needed basis, because most data set nowadays, they easily fit in the RAM of single machines. And I want to share the example here, DuckDB Geospatial. This is a spatial extension for DuckDB to handle spatial joins and various spatial operations. It is a very much efficient way to process the data. So assuming you can have a medium-sized data set for a lot of people, that is maybe 20 gigabytes in size, 100 gigs in size, 500 gigs in size. And you have a server that has, for some it has 60 gigs of RAM, for others it has maybe 500 or terabytes of RAM. Should you use a distributed system to process it? That depends on your use case, but the short answer should always be no. First try with a simple tool, like for example DuckDB, and then it can be much more efficient because there's less knobs to fine tune, less things to learn. It's also more fast for most of these medium-sized data sets because there's less overhead of exchanging data across the compute nodes. I see one more question. Based on your explanation, forecasting is used in spatial analysis. Can you explain how this might relate to weather conditions? So this talk here is in fact only meant as an introductory talk. So I will not be able to deep dive into this question. As a very shallow high-level answer, you would want to combine various data sets, satellite data about how the temperature of the sea is, how the clouds are moving, and the past weather, and then forecast how this will change in the future. There, as mentioned, Google recently released a new data set. Let me quickly check. It's this weather forecast I effected 4 days ago. It's called GraphCast, and I will share it in the link. Might be interesting to deep dive and look at this, but this is a very advanced way of combining the data sets for what graphic or geometric deep learning in the spatial domain, but it could still be interesting to look at it. The next question that came up is, I have tried to get satellite data, but it is still medium resolution, Landsat and Sentinel, when do spatial classification. Is there a reference for obtaining high resolution satellite image data that is open to the public? So there is the Geo Engine. Google, what is the name of it? No, it's called Google Earth Engine. And that is, in fact, a cloud platform by Google that is housing various geospatial data sets and satellite data. Some might be commercial, some might be non-commercial. I mean, open to the public also includes commercial, I guess, or maybe not. It depends on who's asking it. But if it includes commercial data, there are various providers that you can buy it that is open to the public and not only for, let's say, military purposes. But Google Earth Engine itself as a platform houses already various data sets and processing power. So it can make it very easy to work with these large-scale data sets. And it's already pre-prepared, so it might be an option to look into. Let's move forward with the talk. Some other geospatial statistics method is clustering. Usually it is based in the traditional non-spatial domain about the attributes, but in the spatial domain, the geolocation has to be added and taken into account. We have more or less two ways to process spatial clustering. One is to extend a traditional method like k-means or hierarchical clustering or whatever, let's say dbScan with spatial properties. And the other option is to use a method like a scatter, that is spatial cluster analysis by tree edge removal, that is constructing sort of a spanning tree, like a graph node network, and then it tries to remove non-required connections to then in the end form the clustering groups. And that can also potentially include not only the spatial domain, but also the attributes when you have a joint clustering method. There are always in the slides a couple of links that allow you to read much more up on the methods. An important option is also Kriegering, because of spatial interpolation. In particular, if you want to forecast things, the Gaussian process regression or regression within these, let's say, preconditions can be a very interesting thing to do. An alternative to the traditional Krieging methodologies could be the inline methodology, but now it's getting quite advanced. Still, I think it's good to drop the names, share the links, so you can then deep dive on your own on an as-needed basis. Why? Because it sometimes might be more efficient than Krieging, because that is also one of the, let's say, rather slower to compute algorithms. Talking about slow, the GT's odd is also slower or complex one, as you see many things to sum up, or and looking at it from a, let's say, IT perspective, quite high complexity. If the data is high, this function to compute this function over a large data set can be challenging. Why would you want to compute it? Because you want to figure out spatial outliers, like is there a difference, a hotspotting that is significant, for example. And in fact, this is a core thing that Uber had to do to figure out the dynamic pricing. And they were thinking, what can we do to make it work? And there, with H3, IJK, let me see if I can quickly show a nice picture about it. Yes. With the hexagons, they created this efficient indexing system, and to basically retrieve the neighbors. And you can basically from one cell connect to the neighbors, as also shown here. And that is already suitable for many people. And if you run a, let's say, batch job in a big data, you can scale it up. But Uber needed something that was even more scalable to the global needs, but also something that works fast, because the search prices should really detect price changes in almost real time. And what we figured in deep learning, we have a similar operation. It's called the convolution, that can sort of figure out, analyze the surroundings and then reason about them. And they basically changed the coordinate system from this hexagonal space into a different one. And then you can still apply the deep learning traditional convolution operator in an efficient way to then compute similar metrics. Last but not least, machine learning or spatial machine learning is getting more and more interest in recent years, in particular about identifying objects from space. Some people are looking into the base yards of people to figure out if they have a swimming pool and then perhaps tax them if they have, or analyze other objects. Let's say analyze deforestation in rainforest and then track where perhaps people are doing bad things. That is the end of the talk. I hope it was an interesting introduction for you. Please ask any questions that you have remaining. And other than that, I would be more than happy to connect with you on my website, on LinkedIn as shared before, or by other means, maybe at UII when I'm visiting again. Let's see.
Okay, thank you very much, George. He doesn't like me to call him professor, so now I'm calling him George. Okay, participant, do you have any question? The presentation already been shared in the chat box, so you can download it. Hello? They already been asked you a lot of questions. Maybe we wait some other to have some question. I think more or less actually they would like to have like hands-on or practical, but it is not this time. So in the future, maybe we will try to arrange the hands-on workshop with George Heiler and also with Professor Hassani. Okay, if you are interested to join the workshop later, so please tell us, because we will have some, how to say that, not quiz, but it is maybe more to something like a suggestion about our event for today. Okay, let me ask you again, do you have any question or do you have something to tell to George? Please let us know here directly, or maybe you can writing in the chat box. If you don't have any questions, so now probably I have a question. George, you talk as well about big data in here, okay?
Yes.
So if you would like to learn about this big data related technique, either maybe using MongoDB for database or something like that, how long actually we should learn? Not about long life learning, but just like estimation based on your experience. Yeah. One semester or 2 semesters, I don't know. Yeah.
That depends on what you want to achieve. Like if you want to build a new generation of large-scale data processing systems, you will probably need to learn a lot, and much more than a university can offer. You will need to actually work on the job with other distributed system engineers in the big, let's say, fund companies where they're doing this. But you will need to learn the fundamentals of distributed systems. But most people don't want to do this actually. For them, they're more applying and using these systems. And this you can learn much faster. And in fact, nowadays, most people don't even want to use these systems anymore by working with the cloud databases, but have an inbuilt geospatial function. And they can talk to these using SQL. So you can basically, once you learn PostGIS and understand the geospatial additions there that run maybe in a Docker container on your laptop or on a server, then you can basically extrapolate this knowledge more or less one-to-one to these big systems. So there's a little bit of an overhead to learn for sure, but not much. if you're looking at these very modern large-scale processing systems.
Okay. Based on your experience, actually, I would like to. Oh, okay. There is a question from Alicia. Okay, Alicia, go ahead.
Good morning, sir. My name is Alicia. I'm from the undergraduate program of International Program for the Statistics. I would like to ask about the forecasting itself because we know that recently there has been a spike of global warming, and I'm pretty sure that kind of shift the weathers, what's it called? The seasons for Indonesian, at least there are shift between the rain and dry season to a few months early maybe. And do you think it would affect even more in the forecasting in the future, as it has become pretty irregular as of recently?
I think it's even more complex than that. This is only one aspect to it. But this is a general thing, what you are mentioning, that if you're doing forecasting, irrespective of spatial or non-spatial, finding the right context and figuring out how much old historic data is actually still useful or applicable to the current situation, that is a challenge. But in this particular context about weather forecasts, sometimes unexpected events do happen as well. So, for example, the 5G rollout, let me maybe get some link as a reference. So 5G is the mobile phone network, the new version of it. That is interfering on some frequencies with the, I think, temperature measuring of the satellites on the sea. And that is obviously a big setback for figuring out a core sensor part of let's say, weather forecasting chain. So there sometimes unexpected things can also happen.
Okay.
I understand. Thank you for your answer.
Okay, and next there is a question from Bu Ani Budi Astuti, which is a lecturer from University of Brawijaya, another university in Indonesia, in Malang. Can you see that in the chat box?
I cannot see the Bayesian spatial modeling is often hampered by setting parameter. What are your thoughts on the Bayesian approach estimation? That is a complex question. Like, I can only give you a generic answer to this, and this is applicable not only to spatial but to non-spatial Bayesian methods. Like traditional university is not teaching these methods enough, and they should, because it is the most, like the basic fundamental assumption about Bayesians is you have an initial assumption about a problem that you want to solve. You receive more data or measurements from the surroundings, and then you update these assumptions of basically the outputs. And then you iterate until you converge. And I think this is a good thing. Can a strong prior influence the outcomes? For sure, it can. But what if you choose a weak prior? Then these can almost be non-existent. A lot of people coming from the traditional domain hope for some automatic means of a black box, pressing a knob and getting stuff done. But this is, I think, the challenge of modeling, to find the right models. And in fact, to also find explainable models. And there, in the domain of Bayesian analysis, it's super easy to add some more effects, or it's at least possible and easy from the framework perspective, where traditional means are much more restricted.
Okay, Bu Ani. I think maybe okay. So once more, do you have any question, participant, please? If not, maybe we can terminate the meeting with George, okay? And then thank you very much, George, for your presentation, sharing your knowledge with us, which is about spatial statistics, which is basic concept in spatial statistics. I hope that in the future we can have a hands-on workshop with you, okay? Maybe we can arrange another time. Before I hand it back to the master ceremony, Mbak Zahra, can you provide me the certification for George, please? So we would like to give the appreciation thank you to Georg Heiler, which is first, this is the certificate. Is from us, George, and then we will send it by email later or by WhatsApp, okay?
Yeah.
Okay, before I'm terminating this session, let's give the applause for Georg Heiler. George, thank you very much. Okay, now I'm handing it back to Mbak Zahra. Mbak Zahra, please, the time is yours.
Well, thank you very much once again to Professor Heiler for delivering this very insightful material to all of us. And also thank you to Ms. Emma for moderating this session. Well, ladies and gentlemen, before we come to the end of this webinar, SBRC webinar, let us close this event by saying Hamdalah together.
Alhamdulillah.
And also, I want to remind all of the participants to fill the attendance form. This is as the requirements for your certificate. And the link is already sent in the chat column. Well, ladies and gentlemen, finally, we come to the end of this SBRC webinar 2023. This is a collaboration event between SBRC and International Program of Statistics Department, Universitas Islam Indonesia. On behalf of the committee, I would like to extend our deepest appreciation to all the speakers, Prof. Heiler and Professor Hassani, that already delivered a very insightful material to all of us. And also, thank you to all the participants for your support in participation. Once again, thank you very much. Keep healthy and see you in another occasions. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Sami-sami.
Matur nuwun.
Again greets us beautifully. A bright and glorious future gives us happiness and perfection. We, the Master Program in Statistics UII, are founded to produce globally competitive graduates in analyzing data and statistical science advancement. The Master Program in Statistical UII is one of the master programs at UII which focuses on business, industry, social, and actuarial, data science, spatial, and bioinformatics. We first established on September 21st, 2022. We provide education according to national standards that are globally oriented such that graduates can play a role at the national and global levels. The Master Program in Statistics UII is a pioneer educational institution that prepares its graduates to become experts in data analysis and integrating the MBKM program. We are located in Professor Dr. Haji Zanzawi Suyuti Building, Yogyakarta Special Region. The Master Program in Statistics UII works confidently, has a strong commitment, and is supported by competent human resources, up-to-date facilities and technology, extensive network partners, experienced and accredited by BAN PT Higher Education. The Master Program in Statistics UII aspires to become excellent in data analytics and the development of statistical knowledge to advance science and technology through teaching, multidisciplinary research, graduates who are competent, flexible, innovative, and have excellence in Islamic principles. The learning outcomes of the Master's Program in Statistics are summarized into creative minds, namely excellence in communication, producing outstanding research, professional entrepreneurs, strong analysis skills, up to date with technology, having Islamic ethics, understanding of differences, responsible elaboration, managerial data skills, creative in innovation, proud to be Indonesian, having diagnostic abilities, and leading in science. To provide the best service for students, the Master's Program in Statistics UII provides international standard laboratories to support the learning process and research activities. They are Risk and Disaster Management Statistics Laboratory, Business, Industrial, and Social Statistics Laboratory, Data Science Statistics Laboratory. Various campus facilities at the Master's Program in Statistics UII are provided for students to get the best experience in studying and doing activities during their studies in UII. We are committed sustainably to developing and improving the service to provide the best educational services. We strive to create a new future through innovation, research, and passion that benefits all humankind. Wherever you are, come and join us and be the best partner of life.